In the last two videos, we talked about comparators and priority queues. So we know that a priority queue will order its elements based on the priority of the elements. Well, if we don't specify a priority, then it will just be based on the ordering the natural ordering of the elements. That'll be the priority. Okay, so right now I have a bunch of strings here, and I want to see what the order is of them if we pull them out. So let's see what we get. So as I sort of alluded to, this is in lexicographical ordering because the default comparison or the default priority of the strings is the lexicographical ordering. But I want to change this. I want to say that I want to prioritize the string Joshua over the string Jack. Okay? So that means that I want to pull Joshua before any occurrences of Jack. And the way this will work is that we'll say that Joshua is prioritized over anything else. Or rather, so actually that's the bad way to phrase it. So Joshua has the highest priority, and then anything else, and then Jack. So Jack has the lowest priority, Joshua has the highest priority. And that anything else will be ordered based on the natural ordering of the strings. So Joshua's will come first, and then anything in between Joshua and Jack will be based on lexicographical ordering, and then we'll have Jack. So that means we need to create a custom comparator for this. So we said last time that we could use these things called lambda expressions to create comparators, but let's just do it the more cumbersome way. So we're going to do create new comparator, and then we're going to have to override this method, which tells us how to compare two strings O1 and O2. Now, if we want to compare two strings and we want to say that this string O1 comes before O2, remember that we said that the value returned from this method is the ordering of O1 with respect to O2, and that's very important to understand. And the thing that you return means that if O1 comes before O2, you should return -1. If O2 comes before O1, it should return 1. So it's like compare to for strings. Okay? So if we want to say that if the string O1 is equal to Joshua, then we should always return -1, which means that no matter what O2 is, Joshua will always come first. No matter what O2 is, Joshua will always come first. Okay? If O1 is equal to Jack, then we want that to return 1. Because if O1 is Jack, then we want Jack to come after anything else. Okay? But there's a secondary condition here. So if O2 is Joshua, then we want to return 1 to say that O1, no matter what O1 is, if O2 is Joshua, then O1 should always come after O2. So we're also going to say or O2 equals Joshua. And the same thing here. If O2 is equal to Jack, then no matter what O1 is, O1 had better come first before O2. Okay? So or O2 is equal to Jack, then we return -1, and then here we return 1, and then otherwise we're just going to return O1.compare to O2. So if either of these cases don't apply, then O1 and O2 are not Joshua nor Jack. So they're two different strings. And we're just going to compare those using the natural ordering of the string. Okay? Now how do we pass this comparator to the priority queue? Well, we can just, all we have to do is inside of these parentheses, we're going to call the create comparator method. Now it's important to know that we could have just inlined this right here. Okay? So you can inline the comparator creation process directly inside of these parentheses. But I think that's a little cumbersome to write. I'm not a big fan of this, and that's why the lambda notation exists. So, we could do like O1, O2, and then define the comparator this way. But I'm not a big fan of this either. I'd rather just create a separate method and then call that here. So the comparator returned by createComparator, which admittedly this isn't the best name for this method because it doesn't say what the comparator does, and we don't have Java docs here, so that makes it even worse. But just for this small example, we'll go with it, and because there's only one instance of where we're going to use this comparator, it's not completely egregious. Okay? So let's see how this works. So if we run this, we should get the following order. We should say it should be Joshua, and then it should be Jane, Jared, Jasmine, Jenny, Jesse, Jill, John, Jonah, Joseph, and then Jack. Okay? So let's see how this runs. And indeed, that's what happens. Okay? Joshua's prioritized, then we have everything else alphabetized, and then Jack. Okay? If we wanted to reverse this comparison, we could say, like if we wanted this to be in descending order, we could say return O2 dot compare to O1. So if we want Joshua to come first, and then everything else in descending order, we just flip this comparison. Okay? So that's how to use a comparator with priority queues. And this is pretty much what you're always going to do. Okay? You're usually always going to create a custom comparator for a priority queue, because otherwise it just uses the natural ordering of the elements, which in, I would say, all but maybe a few cases, you don't really care about. There is one particular case where using the natural ordering might be nice, and that is to sort a list of integers. Okay? And I'll do that in the next example.